Imagine a world where your typing habits become your password. That's the essence of AI-driven behavioral biometrics for IoT device authentication. Instead of relying solely on traditional passwords, this innovative approach analyzes how you type, your unique keystroke dynamics. Every time you log in, the system captures the timing between your key presses and releases, creating a distinct behavioral profile. It's not just about what you type, it's about how you type it. This dual-layer security significantly reduces the risk of password theft and unauthorized access. Using a random forest classifier, the model learns your typing patterns, ensuring that even if someone knows your password, they can't mimic your unique style. The result? Enhanced security without compromising user convenience. As we move forward, imagine integrating deep learning for even greater accuracy and applying this technology in high-security sectors like banking. This is the future of authentication: smart, secure, and uniquely you.
Welcome to our presentation on AI-driven behavioral biometrics for IoT device authentication. Today, we'll explore how machine learning can enhance security by analyzing user behavior. Machine learning automates decision-making processes, enhances prediction accuracy, and adapts to new data without reprogramming. It has real-world applications in healthcare, finance, retail, transportation, and smart homes. Traditional authentication methods rely on passwords, which can be stolen, guessed, or shared. Behavioral biometrics, such as keystroke dynamics, provide an additional security layer by analyzing how a user types a password. Passwords alone are not enough to ensure strong security. Many users tend to reuse weak passwords, making them easy to hack. Even strong passwords can be stolen using phishing or keylogging attacks. A system that verifies both password correctness and typing behavior can improve security. Continuous advancements in deep learning, reinforcement learning, and transfer learning focus on explainable AI and ethical ML. Existing ML models include supervised learning, unsupervised learning, deep learning, and reinforcement learning. Current solutions face gaps in transparency, high data and compute dependency, vulnerability to bias and adversarial attacks, poor generalization, and limited real-time adaptability. Our solution uses machine learning to analyze and authenticate users based on their typing behavior. Users type a predefined text multiple times to train the model. During authentication, the system verifies both the password and keystroke pattern. If both match the trained data, access is granted. The implementation involves data collection, feature extraction, model training, and authentication process. Users type a chosen sentence multiple times to capture typing patterns. Keystroke data includes press and release time differences for each key. A random forest classifier learns the user's typing behavior, and the trained model is stored for future authentication. The model workflow includes 6 steps: typing the training text multiple times, recording keystroke timings, extracting features, training a machine learning model, verifying typed password and keystroke pattern during login, and granting or denying access based on the match. The code is written in Python using libraries like scikit-learn, pandas, numpy, time, and pickle. Keystroke data collection captures the time between key presses using time. Model training uses random forest classifier from scikit-learn, and the authentication process loads the trained model and compares new keystroke data. The model successfully recognizes an authorized user's typing pattern and rejects unauthorized users with different typing behaviors. The system remains secure even if someone knows the password but has a different typing style, improving security over traditional password-only authentication systems. Keystroke-based authentication adds an extra security layer to IoT devices, ensuring only genuine users gain access. Future improvements include enhancing accuracy with deep learning models, expanding to multi-device authentication, and using this system in high-security applications like banking and online exams. Here are the references that support our research and findings, including key texts on machine learning, deep learning, and AI. Thank you for your attention. We hope you found this presentation informative and insightful.